Hey, 6th grade, it is Mr. Frazier. This is our science lecture for Tuesday, March 31st. I hope you guys are all doing well. Today's lecture is a little bit short because we're coming to the end of our chapter. Just a few announcements at the beginning of the week. First of all, for those of you who have not heard, I have postponed our country report indefinitely until we figure out what we're going to do. We're scheduled to come back after spring break. I don't know if that's what's going to happen. Excuse me, got to drink a little water. But once again, in previous years, I met with students and we did little bite-sized assignments. I don't think it's fair to ask you guys to write this huge paper that you've never done anything like it before at home without my help. If we stay out of school for longer, then maybe I will create a shortened assignment or something else. I'll think about it. But right now, don't worry about your country report. Just worry about catching up with your main assignments. Now, speaking of main assignments, most students have turned everything in, but not everybody has. So in this week, I have only assigned 2 homework assignments, and I'm going to send out lists of the work that people are missing. So if you've turned everything in, you will get a email that says, keep being awesome. If you haven't, then I will have a list of your assignments that you need to do. If you are having trouble like with the worksheets with Dropbox, if you can't see the assignments or I'm not doing it right, let me know. I can email them to you or text them to you. Turning them back into me should be really easy. You can just take a picture of them and send them to me. I can scan the picture. But please, please, please get in touch with me. Also, we have tests this week. I moved our history test. Check your parent letter for the exact details. So I will be posting the test onto Dropbox unless you're somebody who wants me to email it to you. You're going to print the test out. You probably have done this with Miss Alanis already. Print the test out, do it, and then scan it and send it back, and then I will grade it. Anyways, I know that's a lot of information coming at you. If you have questions, let me know. Don't fall behind. I know we got a lot going on. We're all reacting to everything. But we need to stay on top of things. Got to keep on getting through school so you can graduate from 6th grade. And I am always available. Anyways, without further ado, here is your science lecture. So we talked about caves and fossil fuels last week. Remember, a fossil fuel is any fuel source. If something that is fuel is something that you burn or use for energy. And fossil fuels are fuels that are created by the fossilized remains of organic matter. So dinosaurs, plants, organic material, things that were once alive, are fossilized over the course of long periods of time through heat and pressure, and they turn into something new that you can use for fuel. Mostly we use the 2 types, coal and petroleum. We also talked about caves, the different types of caves, and the different types of cave formations. Remember, all cave formations are made from a substance called calcium carbonate. And now that we have finished all the caves and all of the petroleum and coal talk, our last section is about Earth's magnetic field. Earth's magnetic field is extremely important to all life here on Earth, and we're going to talk about why. Earth's electromagnetic field is a force field, and it surrounds the Earth. Now, not every planet has a magnetic field. In fact, very few do. All the gas giants, like Jupiter and Uranus, do not, because they do not have a metal core. In the beginning of the chapter, we talked about the different parts of the Earth. The inner core is made of solid metal. The outer core is made out of liquid metal. And as the Earth spins and rotates, the outer core rubs against the inner core. And that friction creates an electromagnetic field. And as long as the Earth continues to spin, which it will for billions of years, we will have this magnetic field. If it were to ever stop, that would be the end of time. But the Earth's core, thousands of miles beneath our feet, creates this force field that surrounds the Earth and protects it. The reason compasses work, the reason that we are not all boiled away by the sun, is because of this invisible shield that surrounds us. So remember, the Earth's magnetic field comes from the core. It's the metal, the nickel and iron in the core, as they rub together, creates this electromagnetic field. Now, if we want to talk about the Earth's magnetic field, we got to know about magnetism. What is magnetism? Pretty self-explanatory. It is the force that pulls magnets together or pushes them apart. I am sure that all of you have had magnets before, whether you got them at some museum gift shop on a field trip or just the ones that stick to your parents' fridge. A magnet affects other magnets and magnetized metals. So you can put a magnet up against cardboard or wood, it's not going to do anything. If you put it up against a metal refrigerator door, it will stick. So magnetism is that force. You can't see it, but it's there. The magnetic field is that area that surrounds a magnet where objects are affected. So in this picture, you can see that those iron filaments, that little gray dust, is being affected by the magnetic field. There is a magnet underneath that white sheet or whatever it is, and the magnetic filaments are being affected by that. Now, at the bottom of the page, it says pokes. Sorry, that is a misspelling of poles. So, if you look at the picture, you see that at the ends, at the poles, you have the concentration, the strongest amount of magnetism. And so, most of the iron metal filaments are at the north and south pole. Magnets work just like electricity. And we're going to see that electricity and magnetism go hand in hand, kind of like volcanoes and earthquakes from earlier. If you've ever used a battery, which I'm sure you have the positive side that looks like a plus sign and the negative side that looks like a subtraction sign. And you always have to put the batteries upside down next to each other so that the positive goes to the negative and the negative goes to the positive. If you put plus side to plus side, it won't work. The same way with a magnet, if you put plus side to plus side, they push apart. Plus side goes to minus side and they pull together. Electricity and magnetism are intertwined. So you can think of magnets just like batteries. There's the plus side, the positive side, and there's the minus side, the negative side. Those two ends are the poles, not the pokes. Sorry about that. All right. The magnetosphere. The magnetosphere is the name for the magnetic field that surrounds the Earth. Earth is an electromagnet. Now, an electromagnet is a magnet that only becomes magnetized with an electric current. That big magnet you see in the picture are normally used to pick up big things like cars or old junk. And if it's always magnetized, well, that's no good because wherever you move it, it's just going to start pulling everything around. So that big metal magnet right there is an electromagnet. When they turn off the flow of electricity, it ceases to be magnetized and you can move it wherever. When they flip it back on, the electric current enters the magnet again, and it starts to attract metallic things again. Remember, electricity and magnetism work hand in hand. Earth is a huge, huge, huge electromagnet. And you may say, well, where's the electricity coming from? It's coming from that current. You can create an electric field or an electromagnetic field by rubbing certain metals together. Those metals happen to be in Earth's core. So as the Earth spins on its axis, it's rubbing those metals together and creating an electromagnetic field. If Earth were to stop spinning, the cores would stop rubbing together and it would cease to be electric or magnetic, and all manner of terrible things would happen. So, an electromagnet is a magnet that is connected or turned on with electricity. The magnets that you get from the gift shop, the fridge magnets that your parents use to put your A pluses on your refrigerator, those are not electromagnets. They work all the time. You just stick them on the fridge. But electromagnets are ones that are connected to an electrical power source. Hooray, we're learning. So, the magnetosphere is Earth's magnetic field. It is huge, it extends out into space. Here's a picture of it, of an artist's rendering. And the Earth's magnetic field extends thousands of miles out into space, and it is the thing that protects us. In the next chapter, we're going to talk about stars and the sun. The sun is like a big ball of nuclear bombs going off every second. And nuclear bombs are very harmful. There's radiation, there's microwaves that are being emitted from nuclear weapons and from the sun. And they're flying off the sun constantly. They're flying so fast, and they are literal microwaves. If you've ever cooked a burrito or something in a microwave, that's kind of what would happen if the microwaves got to us. The solar wind is extremely harmful. The solar wind are a stream of harmful particles that flow constantly from the sun. Now, that radiation can still get through Earth's magnetic field, but only very, 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 very small amounts. But one of the reasons that we put on sunscreen when we go to the beach or whatever is to protect us from the small amount of particles that get through the Earth's magnetosphere. If we did not have a magnetosphere, that solar wind would kill every plant, animal, and human on the planet, and that obviously would not be awesome. So that solar wind is flying at us all the time, but the Earth's magnetosphere protects us. Now you'll notice that at the North and South Pole, it looks a little bit different. And because poles are where the magnetic field is the strongest, we will see that at the North and South Pole, there is a peculiar circumstance happening. And those are called, I'm going to see if I can say it without messing up, auroras. Auroras. Auroras are light displays that occur when solar wind particles get caught at the Earth's poles. So as the solar wind is shooting out across space, most of it hits Earth's magnetosphere and bounces away into the nothingness of space. But certain particles get caught in the Earth's poles and they start to bounce around. And they bounce around so fast that they create luminescence or light. And that aurora is that light that we're talking about. You can see the picture there. The auroras are light shows. Now that's the solar wind, just bing, 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 getting knocked around in the Earth's magnetic field, and it creates that light. Now they're both called auroras, but depending on where you're looking at them, we call them different things. So if the aurora is happening at the North Pole, we call it the aurora borealis. So if it's happening outside of Santa's house, It is the aurora borealis. If it happens in the South Pole, then we call it the aurora australis. Now, Australia is in the southern hemisphere. Now, why didn't they call it the aurora antarcticus? I don't know, but that's what they call it. Aurora borealis in the north, the aurora australis in the south. That is the end of our science lecture today. Um, we're going to have some review stuff on Thursday. We are going to have the test when we get back from spring break. So there's a shortened week this week. There is spring break next week. And when we get back, we will talk about the test. Speaking of tests, the history test that we have on Thursday, I moved it from today to Thursday because we didn't have any time to prepare. Because you're at home, I didn't really think about it too much, but I sent out a study guide just in case. The history test is going to include all of the stuff that is on your study guide, the stuff that's just from the chapter like usual, but it's also going to use the information from the worksheet. The answers are almost the same on the worksheet, so the things that we talked about Caligula, it's just part of the test, but since we did all that keynote stuff, I included it. If you have questions, remember, text me, email me. If you're taking the test and you have a question, call me, and I will help you as much as I can. Anyways, I miss you guys. I hope you're doing well. These are special circumstances, but you're handling it like champs, and I can't wait till we're back in class, doing our thing again. All right. Praying for you, missing you. See you later.